Thanks for your time this morning. So I wanted to talk about modern data strategies for innovation. That's what I wanted to spend some time on, and I can promise you that I will not talk about any of the AWS services. There are 200 plus services, and I don't know how many of you saw the keynote yesterday at reInvent. reInvent is our flagship yearly event where we announce our latest, newest features and services on our cloud platform. Yeah, so first of all, again, I don't know how many of you saw this news. We have launched a new region in India, the Hyderabad region, just about a week ago on November 22nd, 2022, this last week. We made an announcement that we are going to launch this in November 2020. In about 2 years' time, we have been able to launch this in the beautiful city of Hyderabad. It has got 3 availability zones. I'll spend a few minutes on this and I will move on to our main topic because we've just recently launched this. This is our second region after Mumbai region, and this is our 10th region in Asia Pacific and 30th worldwide. We have been making significant investments in opening newer data centers across the world, and our newest is at Hyderabad, and many more to come across the world. So I just wanted to spend a minute about what do we mean by regions, what do we mean by availability zones. They're about same words. So Hyderabad will be called as a region. Within that region, we will have 3 availability zones, and these 3 availability zones are spaced about X kilometers of distance. This X kilometers could be anywhere between 50, 100, 200 kilometers. This will ensure that the distance will ensure high availability. If one data center goes down, there is always another data center which is able to pick up the load and come up and running. And also, the low latency ensures there is real-time data replication, and there are several architectural considerations that we have when you have to design your workloads to ensure that there is a lowest time and latency for replication, as well as ensure that there is high availability. So that's our concept of region and availability zones here. So this is about the region design itself. This is just to go deeper into how an exact availability zone looks like. So within the availability zone, you will have multiple data centers. Again, they are all redundant with respect to power. That's the whole idea. So as you see, there is a region which is called Hyderabad region. There is 3 availability zones, and within the availability zones, you will have multiple data centers. So this is how we have organized our data centers and our regions to provide highest levels of availability as well as highest levels of redundancy. Just a little bit about the investments we are making in India. So 2013 is when we had CloudFront available in India as a country, or what we call as an area. 2016 is when we announced the availability of the Mumbai data centers, and in 2022, just as of last week, we have the Hyderabad data centers also being announced. And in between, if you had noticed, we also announced what is called as a local zone. This is again meant for very high latency workloads where you will be able to run your workloads on something called as a local zone, which is paired with the closest region. So for example, we announced a local zone in Delhi. This is for all kinds of customers who have got very low latency requirements. And Delhi as a local zone gets connected towards nearest region, which is Mumbai, and so Mumbai as a region will have the control plane, and all the workloads and applications will be served out of the local zone in Delhi. We are making further investments in India. We are going to come out with 3 more local zones. The 3 are going to be based out of Chennai, Bangalore, and Kolkata. So that's where our 3 other local zones are going to come out. So if you see the way we have been increasing our investments, we started with the CloudFront all the way up to multiple local zones. Again, the intent is to take cloud closer to customers rather than just keeping it across 2 main regions like Hyderabad and Mumbai. And given that we have got large media and entertainment customers, the streaming that happens across India, so there is a very strong need to ensure that we are able to provide cloud computing infrastructures closer and closer to our customers, and hence we are making these investments in terms of regions, availability zones, and local zones. Right. So I'll spend a minute about what we mean by innovation and what Jeff Bezos talks about innovation, and he says that customers are always beautifully, wonderfully dissatisfied, and that gives us an opportunity to think on their behalf and to be able to invent on their behalf. So this is, and we have got a program called as Culture of Innovation. I will not spend some time here, but I'll just talk about one or two things of what we mean by culture of innovation and how we always work towards innovating on behalf of our customers. And we have got this very nice concept of mechanisms, right? So mechanisms are encoded behaviors that facilitate innovative thinking. So within the organization, what we do is we leverage mechanisms, and one of the things that we do with internally within our teams is, you would have heard of what we call as two pizza teams. We always challenge ourselves as to what should be the next service or feature that should come out of AWS as a cloud, right? So we work backwards and we try to understand who is the customer, what is the customer problem or opportunity that we are trying to address or that we are trying to solve for. So for us, everything starts with the customer and we work backwards from the customer. And anything that we try to come out with creatively, what we do is, we call it as multiple things. And I know the industry also has got multiple names to this. We either call it as a minimum viable product, an MVP, or a minimum lovable product, and MLP. It goes by different names. But before we come out with an MVP and scale it, we do multiple experiments to really see if this product is the right fit for our customers and if we are really solving the customer's problems. And based on the experiment and the hypothesis with which we originally created the experiment, we try to broad base it and come out with a service. So that's the way we define innovation, and that's how we drive the organization to create new and innovative products and services. I just wanted to start with an inspiring customer story, and then I will move on to more of data. So if you look at Capital One, it is one of the largest banks in the US. And if you see this footnote here, the way Capital One defines themselves, while they are into banking, they were founded in 1994. They call themselves as a leading information-based technology company. They don't call themselves as a banking or a financial services organization. They call themselves as a information-based technology company that is on a mission to help their customers succeed by bringing ingenuity, simplicity, and humanity into banking, right? So they have taken it on themselves to ensure that they are a technology-first company and they are able to serve their customers through banking, right? So that's their definition, and what happened with them was they've been working with us for many years now, and they have now moved into cloud completely. So they don't have any on-premise data centers. So in their process of moving to cloud, they recycled 103 tons of copper and steel. They closed down 8 data centers. They had an 11,000 member technology team that was helping them in this migration along with AWS. And they had 50% reduction in the number of transactional errors. And they were able to reduce the time taken for average development from 3 months to 3 minutes while moving on the cloud, right? So this is really, really inspiring, where it was really top-down driven, where they had an organizational mandate to take a call to move to the cloud and shut down all their data centers. This is really, really inspiring, and if you look at the way they have been innovating, they have also given a lot of autonomy to all their independent teams. For those of you who don't know, so the entire idea of balance transfer on credit card was started by Capital One way back in the late 90s. And the way they did this was they had given complete autonomy to their data science team way back in the late 90s and early 2000s to tell them, to tell the senior management what does data tell them, right? So, and the data science team came out and said that, if they are able to do something like this in terms of taking over the other organization's balance, they will be able to acquire more customers, right? So all of this was driven by data, and this was run as an experiment, and then came out this concept of, balance transfer of credit cards. Now moving on to data, a lot of people talk about data, and there's always this question of how should you organize your data and so on. So I'll spend some time talking about, what we tell our customers and what we see with our customers in terms of how are they organizing their data and what this data means, right? So, and all of us knows this, that data is growing, and there is a lot of data coming in through telemetry and IoT devices and webs and applications and sensors and so on, so that's a no-brainer. Interestingly, one of the CIO surveys that happened earlier this year, when we were checking with where do CIOs investments are going and what are the tech initiatives that they are taking up to drive these investments. So number 1 came security and risk management, and number 2 came data and business analytics. So a lot of the tech initiatives that CIOs are driving fell in the bucket and category of security and data and analytics, and it was very, very clear that there was a need to have a very strong data strategy to drive a very strong business strategy, and that's where the investments were going into, right? And then comes this, this question of why do you want to become a data-driven enterprise, right? So again, some data points here. What happens is data-driven organizations are growing at an average of 30% or more. We have seen this, and some of these studies are done by Forrester tells us very clearly that companies which are data-driven are growing at a much faster pace than others which are not being data-driven. And then going into the definition of what do we exactly mean by a data-driven organization, they really treat data as an asset. So they really put data to work, and they treat data as an asset, and data is getting democratized. It is not in silos. Again, this could be very proverbial, but we have seen in many cases that while organizations want to do this, either they have got internal issues where they are not able to do this, or they don't have the right technology to be able to achieve this. And then they have got these unified platforms through which they're able to expose data to all organizations, right? So what does this really help us? This helps us make better decisions, respond to unexpected situations in the market, enhance customer experience, and uncover new opportunities. I'll just take a few examples of how some of our customers have been able to achieve this. If you look at making better decisions, Philips was able to identify at-risk patients, deliver better diagnosis, and create treatment plans to improve patient outcomes. This is what Philips did with data. AXA, another insurance-based organization, they were able to deepen their customer engagement. And Expedia Group, which is in the travel industry, they were able to reduce the manual touch rate for partner payment from 17 to 0.06%, right? So what is common across all this is either they have been able to deliver better customer experience, or they were able to deliver better tangible business outcomes. So what is the path for becoming data-driven? And again, this is from our experience of what we have seen with our customers. They have been able to, first of all, break away from the legacy databases, which is holding them back, where you have got a lot of databases that is running on-premise, and you really want to leverage the power of the cloud and innovate faster and bring better products and services to the market faster. And then liberate your data and make it more accessible and available to a lot more people within the organization. And then leverage machine learning to be able to translate all of this to more tangible outcomes, measure, and to be able to grow. Right, so what does this look like? So our framework is like this, and this is what we tell our customers. The modern data strategy should be across 3 pillars. Across modernize, where you're able to modernize your databases. You're able to unify all your data, your both structured and unstructured data, into a data lake, and you're able to innovate through machine learning, right? So how do you then define a data strategy after knowing all of this, right? So you know that you will have to break away from legacy databases, you need to innovate through machine learning. So how do you define a data strategy, right? So again, for us, data strategy is like this, right? So business strategy and data strategy have to really go hand in hand. So business strategy sets the requirements for data strategy, and the data that you have is going to inform and guide the business, right? So data is going to tell you how fast you're growing, how slow you're growing, are you coming out with new products in the market, what is the customer sentiment looking like? All of this is getting deciphered through data, right? So these two have to really go hand in hand. So there is nothing like a data strategy which is going to be standalone. Everything is being driven for a specific business outcome, and it's really important that you have got the right level of people who are sitting in the strategy team of every organization, who are going to come with the data in hand and who are going to help make the right business decisions and business investments. So this is going to be a bit provocative from my side in terms of how organizations have typically seen and how they have typically grown. So what we have seen as an anti-pattern is, you query everything from an RDBMS or from a data warehouse, right? And today we know that there is explosive amounts of data, and this we clearly see as a anti-pattern. We should be able to have systems in place through which you will be able to query even from data lakes and so on. Again, what is also an anti-pattern is, query everything from a data lake, right? Now that I've got an ability to create a data lake, let me query everything from a data lake, make data available. All business users want data as fast as possible. So let me dump everything on a data lake and make it queryable, right? So this also we see as an anti-pattern. And the reason why we see this as an anti-pattern is there is actually no one tool to rule them all. it is really difficult to say that I've got a one-size-fits-all tool, I'm going to give you this tool which is going to do all the magic for you, and you're able to get everything through that one tool. We really believe that each of this data is very different in its nature, form, and hence what we really believe that is you really need to have purpose-built tools for the kind of data that you have and the outcomes that you're expecting to drive through data. So where do you start? You start with understanding your data, what kind of data you have, who is your audience, who are the business users who are going to leverage that data, and then use the right service to be able to serve the right business users who are going to use that. So I'll very quickly build this slide. Right, so depending on whether your data is hot or not hot, whether it's cold, and whether your data structure is completely unstructured or it is semi-structured or if it is completely structured, you're going to leverage one or more of these data structures that you see to be able to put your data and classify your data. Again, you're going to use probably a lot of ETL tools to be able to move data. So this is really important to know what is going to drive cost, right? So that's also really important. And also the other thing is, how fast you need access to these kind of data. For example, data warehouse is leveraged typically to process petabytes of data rather than something which is significantly unstructured, where you're going to take more time to process the same petabyte amount of data, right? So there are some tools of AWS that's available to help you do this. For example, if your request rate is going to be really low, then you put data into what we call as Amazon Glacier. As the name suggests, it's a cold storage data, and if something that is really hot and you really need it fast, then you're going to use something like Amazon Redshift or something like Amazon Elasticache, which is an in-memory data store. I'll now move on to data-driven organizations. So again, a lot of data-driven organizations have started taking this concept of lakehouse, and I'll probably end my presentation with an example of what is a use case for a lakehouse and how all of this comes together. Again, a lot of open formats are being heavily advocated to be used in terms of ORC or Parquet or CSV and so on. That really helps data to be truly democratic rather than being confined to one particular format. And what we truly believe is, with data migration and streaming services coming into a data lake, you really need all the components that you see here, right from data warehouse to security, governance, the operational analytics, and the predictive analytics that go along with it to be able to serve the business users from a data lake, right? So what are the pillars of modern data strategy? To summarize, it's going to be scalable data lakes, purpose-built data stores for the scale and the cost and the latency through which you need to access data, serverless and easy to use. So if you see the theme that we had come out with last year as well as this year, we have released a lot of serverless capabilities on data. That's again to take away or abstract out the the heavy lifting of trying to maintain multiple data warehouse clusters or multiple Hadoop clusters or multiple machine learning clusters, which is going to slow down, and it's going to need a lot of expertise, time and management to be able to manage all of this. And hence what we have done is, we have kind of tried to ensure that we are able to provide with tools which will help you to have data which can flow amongst these multiple components, and that is what these arrows indicate. So machine learning should be able to feed data into data lakes, and machine learning components should be able to feed data into databases, and I'll talk about that a bit. Why should machine learning be able to feed data into data lakes, right? So again, coming back to serverless, so pretty much every component that we have on our cloud is serverless. So you don't need people to maintain those servers, to patch those servers, to maintain uptime for those servers. So we have made it as easy as possible to be able to run analytics and machine learning on our cloud. So right from the Amazon MSK, the real-time analytics, to Redshift, to EMR, you will find a serverless component everywhere. Now, we came with traditionally, if you had looked at what many of these reInvent sessions did and what our earlier CEO Andy Jassy had spoke about and current CEO Adam Silipsky had spoken about, we come with a very strong builder mindset, and hence we thought that it is best to provide tools and capabilities for organizations to be able to build, right? And while organizations evolve and speed of business was increasing, we had a lot of enterprise organizations saying that they would prefer a lot of these components to be not self-managed, but managed by the systems, where AWS is able to provide these management capabilities. And that is where, again, we worked backwards from customers and came out with a lot of these serverless capabilities on the cloud, right? So, and then what we have also done is, with so much of ML being spoken about, we have now brought in ML capabilities into every service that we are creating right now. So even if you look at something which is very, very simple as, a sorting algorithm, you can apply a lot of machine learning to that sorting algorithm to ensure that it comes out with the best of its efficiencies, which is what now Amazon Research has done with Redshift, right? So we are trying to bring ML closer to data and ML closer to users by ensuring that ML is available as a part of every data service that we have got. Otherwise what we see is our customers spending huge amounts of time and investment trying to put machine learning into a data warehouse like Redshift, where, for example, if you need to do order prediction or anything else, that needs to run on Redshift. So we have taken away that abstraction again, and we have provided machine learning in each of these services, right? So I'll probably, take another minute to talk about a lakehouse example to bring into life all of this in a healthcare industry, right? So once all of this is set up, then what does a real life scenario look like, right? So what happens is, there are health records that are stored directly into what we call as S3, which is where most of the data lakes are being built in HL7 format. They are converted into Parquet so that, any system can read it, and they are obviously kept there forever given the durability of S3 as a service. Now what happens is, constantly in a hospital, nurses always take notes, and whatever they write is really important for doctors to understand what is the current condition of the patient. And that notes is being sent to a particular database, as well as to the unstructured data. Because this is unstructured data, you will have to really put it in a place which understands unstructured data, and we'll shortly see what we do that, right? So what happens is, with that existing customers' data, as well as with the keywords that was there in the nurse's notes, all of this data goes into the data lake, and we have got a machine learning service called as Amazon SageMaker, which will help to calculate a prediction score on the data that was provided both by the nurses as well as the patient's record, which will give a good probability about sepsis prediction and prevention for that particular patient, right? So now you can see that all the data came into a data lake, and then unstructured data in the form of nurses' notes was moved into EMR, which is our Hadoop platform, and all of this data is now being leveraged by a machine learning algorithm run out of SageMaker, which is going to come out with a disease score, right? And then what happens after that? And then these are now again written back to S3, which was my earlier point as to, once you have data into S3 to update that patient record, after a machine learning algorithm has been run, you write back the data into S3, which is going to tell you what is going to be the patient's disease prediction score, right? And after all of this is done, then data is getting stored into, again, a structured database called DynamoDB, or any other Amazon or RDS. You can use any of these structured databases to ensure that all of this data is available in a structured format, right? So this is a classic example of how you could use all of these components, bring it together, ensure that you are able to drive towards a better customer experience, a better patient experience, and a better tangible business outcome with all these data components in place. Without this, you would not be able to feed in a nurse's notes, for example, and take inputs from a handwritten note and come out with a better prediction score with respect to disease. Right, so this is a classic real-life example of how a healthcare organization has been able to leverage data to better their customer or their patient experience. So if you're looking to build a data strategy, what AWS has got to offer is this. We have got a workshop called as Data-Driven Everything, where we will work with you. We will work backwards from your business needs and your data needs, and we will help you to create that vision as well as a technology platform on which you can run your data. And also we have got a data lab where we have got our top data architects as well as machine learning architects and data scientists who can sit with you to create that the minimum viable product or the minimum lovable product, and leave you with an architecture as well as with a prototype through which you will be able to take this forward within your organization. So this is what we are able to do with our customers, and we have done hundreds of these, perhaps thousands of these across the world with our customers. Again, by the way, both of them are not, there is no cost associated with this. We do this at zero cost with our customers, right? So, so that's what I've got to share today. Let me know if you've got any questions, and thanks again for listening.